Hello and welcome to Sommer Messtechnik. My name is Matthias Kaufmann and I like to show you how to create a river profile in the Sommer RQ Commander modeling. For this I kindly ask you to open the RQ Commander and switch to the Profile tab. I got this list of river surveying points, meaning from this zero reference line, which is probably the bottom of a bridge. Our surveyor did a measurement with a stick gauge measuring down from that reference point to the bottom of the river, and I got all these values. So now I want to create this river cross section in the RQ Commander. The first option is to key in these points manually. Since I have positive values and I was measuring the distance from my reference point down to the ground, I have to use distance to ground. The other option would be sea level or height, depending on how I get these coordinates of my reference points. So I switch the distance to ground, and with a right click into the bottom left window I can insert a point. So my first point is 0, 0, it's very easy. Again a right click, and now I have to key in my distance, which is 1 meter at a width of 0.5 meter, and it immediately starts drawing my points. So I add another one, 1.2 at 1 meter, 1.4 at 1.5 meter, and so on. I will continue to the last point. Now I have keyed in all these points. We see that's a nice symmetrical profile. It's just for a sample. Looks very much like the one in the Excel, so I have no typing errors. So I can remove the distortion here. So if for very wide rivers it's better, you better see changes in the cross section if you use the distortion, otherwise it becomes really flat. For this sample it doesn't really matter a lot. What you can see, we still don't have any Kfactor. That is because we did not mention the radar position so far. So let's make it simple. For this example we put the radar right in the center, which is 3 meter, and now we have to activate these points here. So that's my actual discharge table, and these points were automatically calculated from the profile list. Especially here in the bottom area I want to have some more points, so I can select this line here, right click and say insert, and it inserts another point for my discharge table. I can see here that's marked with an M, that means it's manually inserted between this 2.5 and 2.44. I can insert a few more points. So especially in the lower flow condition I want to have the Kfactor calculated very accurate. So you're not limited with the points in the profile list. You can add as many points, or more or less as many points as you want. The more accurate the profile is, the more accurate is the cross section, and that will have a big impact on the accuracy of the discharge calculation in the end. For this discharge list and discharge table we are limited to 16 points. So now we have 11. That means I can add some more maybe up here to get a nice K value. This K value is calculated depending on the cross section, on the shape of the cross section, calculated for each water level, and it depends on the roughness. You can either leave it at 100 gravel bed, or you can change to brick stone walls somewhere. We have also natural walls, clean concrete walls. That's the one I was looking for. So let's assume this is an artificial channel, and you can see it has a big impact on the K values if you change the roughness. Another point is, now if I leave it like it is, I have a negative water level. Obviously I don't want that, so I set my 0 point. If you click in here, here appears a small button. Please press that button, and now I can shift my reference system, my coordinate system for the water level. So let's assume the bottom of the riverbed, that means distance to ground 2.5 meter, equals to a water level of 0. It could also be less than 0 probably, or depending on your coordinate system which you have or which you use for the water level. So now it starts counting my water level from 0 up to 2.5 meter. The 2.5 meter water level would be the reference, would be my 0 reference point here. Good. Now you've already created the profile. That's all. You can do a plausibility check, friends. So with a quick discharge calculation. So let's say we assume a water level of 1 meter, and we assume a velocity of 0.8 meter. Then we get a discharge of 1.17 cubic meter per second. The cross section would be 1.9 meter. So one more thing to show you is, if you change the radar position, let's say to 1 meter, it affects of course the K value calculation, and it deselects all these points. And if you try to click it, it says there's no flow velocity measured at this level, which is quite obvious, because if the water level drops below this water level here, the radar cannot measure over here in the center. So let's shift the radar position back to the 3 meter to be able to measure also the lower flow. So now we have to select these points again. Once you have created this cross section and you are connected to the RQ-30, which I'm not at the moment, you have to press send discharge table to load the discharge table to the RQ-30. Yeah, please don't forget to save this profile. Usually profiles are saved in all our software is saved in DME, in the root directory, DME, RQ commander, profile, and let's name it whatever, sample. That's it. There is another option which is maybe a little bit easier, since we have the data already in Excel, and that could be a list with maybe 100, 200 points. It would take a lot of time to key in all these points manually. So let's create a new profile, and now I'll show you how to import the data from a CSV file. So please select File, Import Profile. I've prepared a CSV file from that Excel. Press Open. So now you get the Import tab. My measurements or my parameters start at the line 2. End line is 14. That's probably the last. Yes, that's the last value. My separator is the semicolon, and decimal separator is the comma. It could also be a point, especially if you are in English format, then it might be a point. Yeah, then I press OK, and hooray, we have the profile very quickly. So now again, radar position 3 meter. Then I can select my discharge points here for the K value calculation, and again I can insert manually some points, same as before. You can also do the zero correction. That means a height of minus 2.5 means a water level of 0. Yeah. and this profile again can be uploaded to the sensor. That's it. Thank you very much for your attention. If you have any questions about the RQ commander modeling or the parameterization of the RQ-30, please don't hesitate to give us a call. We are always there to help you. Thank you very much.